Hello, my name is Chris Ayers. I'm a senior customer engineer with the Azure for Fast Track or the Fast Track for Azure team here at Microsoft. We're part of Azure Engineering and we help our customers implement solutions at scale. One of the things that we found is there's a lot of questions around building production IoT solutions. Um, IoT solutions and IoT applications are part of your bigger solution that you build on Azure. And so we want to talk about that today. We have a number of people that are talking about various components as part of our IoT training pack. And we'll show the URL to our documentation and our GitHub as we go through this. But we're going to talk about IoT solutions and apps today. We're going to talk about what DevOps is and, you know, our reference architecture. We're going to talk a little bit about infrastructure as code and how, various components of our IoT apps like Hub and IoT Hub DPS and monitoring can fit into your DevOps solutions and how you can apply DevOps to your IoT. So let's start with DevOps, what it is. The definition I love and the one that I usually lean to is DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. A lot of times, what this means to me is, our users don't care if we've deployed things out to a dev environment or a QA environment. They care about value in production. And so I really like being able to have multiple environments and have it automated and use infrastructure as code to define things once and deploy it out to multiple places to streamline how quickly I can get something tested and deployed out and to repeat things more often. And one way I do that is through infrastructure as code. Now, when we're deploying on Azure, we have a lot of choices. We have a lot of options. We can use the tried and true method that many of us have used for a while through ARM templates, Azure Resource Manager. We can leverage some of the new technologies that have come out over the last year or so through Bicep. And Bicep is phenomenal. I'm going to show you some stuff today with Bicep because it's really good. We can leverage Terraform. Maybe we are very familiar with Terraform and we want to leverage Terraform to create, as part of our bigger applications, the infrastructure components needed for Hub. We can do a CLI, so we can run our CLI commands. And in some cases, we still want to leverage the CLI for some of the capabilities of IoT Hub. We can also use PowerShell or just REST calls as part of our solutions. And as I mentioned, today I'm going to show you some demos and some samples on how we can leverage Bicep to build out bigger applications with IoT Hub at the center of it for communicating with our IoT devices. Now, I covered a bunch of those different technologies and infrastructure as code, and I just want to give you a small glimpse into some of the differences. If you're building IoT applications, you might not know what choice to pick. And if you're already building applications with DevOps at the heart of it, you might leverage one or more of these. ARM and Bicep, they're fully integrated with Azure. They support the latest features of our resources day one, so there's no delay. It supports, access control. We have policies tagging, and we can leverage pretty much any reference to another Azure resource. And there's some great documentation out there for it. Terraform is community supported and supports multiple clouds, and it has some state detection and drift detection. This has some great documentation as well, and all of the resources we're going to be talking about are supported through Terraform. Terraform can lag slightly for some support of brand new features, which is why I usually recommend ARM or Bicep. And then the CLI, it supports more imperative commands if you want to do it that way as opposed to declarative. But the CLI lets you not only query but create and manipulate the resources. It leverages REST calls under the hood like PowerShell does. So as soon as there's a capability available through a REST call or through ARM or Bicep, it's supported in the CLI and PowerShell. And I've provided documentation links on all of those. And reason that we love using infrastructure as code, this is the one that I hype all the time. And so instead of building these resources in the portal, I always try to recommend building stuff as infrastructure as code, you get speed and simplicity. Like once you've implemented it at one time in infrastructure as code, you can deploy that multiple times. You don't have to have these checklists. Did you manually type it? Did you check the box? Documenting multiple steps that you have to follow. It's coded. It is code. And so that means you can code review it, you can reuse it, you can use it as a module, and that makes things more flexible. You can create a test environment and then you can destroy it. If someone's building a new feature and they need to test it out, you can create an environment just for them. And that development team can work in isolation without impacting the rest of the company. If you want to do extensive testing, you can create an environment and then destroy it and shut it down when it's not in use. So you have more flexibility that way. You can have BCDR environments by creating multiple copies of things very quickly, knowing that the configuration is going to be identical. And so that reduces risk across the board. I've included links here to infrastructure as code as part of our cloud adoption framework. This is our way of, describing adopting the cloud like Azure. So let's talk about our IoT solutions. We have so many different types of IoT apps, which have a lot of components. We have devices, and these might be IoT sensor devices that are small, Raspberry Pis or SB32s that live on the edge and send back data, temperature, pressure, humidity, light, whatever that might be, images. Then we have, as part of our solution, we're going to need some sort of way to ingest that, provision that. And that's probably our IoT Hub and our IoT Hub DPS. And so we're having to worry about certificates and authentication. And then as data comes into our system, we're probably going to have a hot path for monitoring and doing analysis, and maybe a warm path or a cold path, where we're storing our data out in a storage account, routing it through functions, or into a Kubernetes cluster for processing. We have management and business integration. Maybe we're doing Power BI or Logic apps, web apps and APIs. We have so many different components that can feed off of this data coming in from our IoT solutions. And so IoT apps, IoT Hub, and all of the technologies involved with that are usually a small part of the overall application. And I want to make sure that the understanding is, if we're doing DevOps across our apps, where we're building and releasing APIs and containers, we can do that with IoT Hub and IoT resources. And if we're building brand new IoT applications, we can apply this methodology and this mindset of DevOps that we use throughout the rest of our application development. So let's look at a sample application. This is one you might find out in our Azure Architecture Center. You might use some of these components. You might use all of these components or some combination thereof. Like I said, we've got our devices out there. Maybe they're running an SDK, or they have RTOS, or they're part of Sphere. We might leverage IoT Edge. Edge is a container-based solution, but it can act as a gateway for disconnected devices. And all of that can get out to our hub and our provisioning system or service. We can go through our hot path and do stream analytics, and we can feed that into Power BI. We can look at our data through Data Explorer, and then we can do machine learning and Databricks, through some of our other paths. And so you can see there are so many different PaaS services and SaaS services that we offer at Azure that all can work together to pretty much build anything you can imagine. And I just want to make sure that we start applying DevOps to these as we dive in. So IoT Hub. This is one of the core pieces of IoT solutions and applications. Like I said, it's one of the ingestion points. It's also where we communicate with our devices and our data streams. It is a fully managed device. And this is how we can allow our secure and reliable connections. We have to deal with things in configuration around like identity and authentication. We have to worry about communication protocols, monitoring things through telemetry, understanding the individual devices, properties, issuing commands, if we're doing a cloud to device command or a device to cloud command. And as data comes in, getting that feeding out through endpoints and routing the messages to the right place. So I want to take a little bit to just quickly examine how we can configure our hub and how we can configure this through infrastructure as code. This gives us a couple of the capabilities we have here. So you can't configure everything through infrastructure as code, but we can configure a lot of things. Like around networking, if we want to do some private routing, or if we want to control public access or DNS, we can configure those in ARM, Bicep, Terraform, CLI. We can adjust the identity and certificates through our security options. We can scale out our hub through infrastructure as code and through CLI, through changing the SKUs or adding more units or modifying things like our consumer groups, how data flows out into the cold and hot paths. All the documentation is there out in our ARM templates and our REST documentation for Hub. And so we're going to look at that. We're also going to look at our device provisioning service. This is one of the services that help us manage IoT devices at scale, where we might have multiple hubs geolocated around the world, or you might have so many devices that you want to round robin or load balance pretty much, making sure that you don't have too much load on one IoT hub. So DPS allows that capability, and we can configure our IoT Hub DPS, and we can, through infrastructure as code, link it to one or more hubs. We can mess with our identity certificates, and like I said, we can link them. So I've talked enough. Why don't we dive down and actually look at some Bicep files, look at how we might interact with IoT Hub and IoT DPS through Bicep, and then we'll look at a quick pipeline on GitHub to see how we might deploy that out to Azure. And so here is a Bicep file. So Bicep is a way we define and deploy infrastructure as code, as we mentioned. Now I've got a link here out to the documentations on the templates, and we're dealing with a resource, and you can see some of the parameters we're taking in on like our consumer group names or capacity units. And just like with an ARM template, we're specifying, hey, we want to deploy out a hub and we're going to use a certain type of API. We can in code define the name, location, what type of event retention we want to support. We can talk about delivery message type. We have a lot of power in configuring this. And so you can take this template and build it and deploy it out and create your dev environment where you're defining message paths, where you're setting up how many SKUs you have. And then you can deploy it again out to something like production and increase the SKU size or increase your capacity units. You can test in dev, I need a certain consumer group and I need to define it named CG1 or hot path or cold path. And you can build that out as part of your overall solution. I mentioned our DPS. We can create, our IoT hub, and we can create our provisioning service, again, using the same type of REST documentation and ARM template documentation. And in this case, maybe we want to make 3 different IoT hubs in East, Central, and West US. And we can use some of the capabilities of Bicep to create multiple ones. We're looping through hub locations, we're creating multiple hubs, and then we're linking them automatically into the provisioning service based on whichever hub you're closest to. We can even link in certificates and pass in a certificate content. I mentioned, creating those endpoints. You saw I had a consumer group. In this case, maybe we want to build out a storage account. So, we need a storage account to store our monitoring logs, our messages, our telemetry. So we can create a storage account, and then we can create containers in that, which are essentially folders. And we can link them together with our IoT hub. We can We can create endpoints, and we can route messages to be stored automatically into our storage account. I'm not even dealing with passwords. I'm not getting passwords and copying and pasting them. I don't need to go out to the portal to create this. Just like with the CLI, this is automatically wiring things up for me. And so we can have our hubs and our DPS, just another tool we can use in building our solutions on Azure. And just like with a lot of services in Azure, we can deal with diagnostic settings. So if we want to gather all that telemetry, auditing, we want to deal with all the logging out in Azure, we can capture that and have it sent out to a log analytics workspace to show up in Azure Monitor. Now, I mentioned we're going to have a pipeline to deploy this. Well, we have a lot of documentation around how to have Bicep and as part of your CI/CD process, where you want to lint your Bicep code to make sure that it is clean, and you want to look for issues in your code. Well, we can lint our Bicep files of our IoT devices. We can, using ARM deploy, we can actually validate out to our Bicep files. Do we have the right permissions? Do we have all the parameters matching? We can preview and run a what if against our Bicep files and see what changes are going to be made. And then we can deploy them to Azure. So let me bring that up. So this is that pipeline I just showed you. So we've got GitHub automatically linting our code and telling us if there are issues with our Bicep file. And it's going to validate, just like I mentioned, do pre-check. Do we have permission? Do we have all the parameters? Does everything line up? We can pause and do a what if and go, what are the changes that are going to be made? What subscriptions are we deploying it to? Resource group, what properties are we setting? What is going to be changed and manipulated? And then we can deploy it out automatically through our ARM templates. And if we go and look out in Azure, it's created a hub for us. And we can, I had mentioned I'd wanted an endpoint, CG1. This is automatically wired up and created a consumer group for us as defined in our infrastructure as code. So I can go through and test this in my application in dev. And if this works successfully, I can then apply this out to a QA or a test environment, to a production environment. We can use this with things like DPS to manage our enrollments and have test devices that are for testing out our solution in our dev and test environments before we start rolling it out to our production environments. Now, all of this documentation, as well as all of the samples, are available out in GitHub and on GitHub pages. This is our IoT production training pack that this module is a part of. This has a number of things we've already built, as well as many more that are coming. So if you're trying to build IoT solutions and need to understand certificates or data egress or IoT edge or how we can do some of these DevOps things, all that documentation is out here. And you can search, or you can go up here to the IoT training pack on GitHub, and you can find all of our documentation and all of our modules out in the repository. And with that, I just want to make sure that we understand, to our DevOps folks out there that love DevOps, we can extend all of the DevOps practices that we love to use, infrastructure as code, pipelines, linting, validation. We can apply those to our IoT solutions. We can, treat our IoT services just like any other Azure PaaS services and configure them and link them together and reference them in ARM, Bicep, Terraform, CLI. And so we shouldn't be isolated to using the portal as we go through building these solutions. We should be able to use the technology to have BCDR and scalability and reliability and all those things that we get from DevOps. And to my IoT app developers, I just want to make sure that you understand it's awesome building a new application or solution, but you don't have to rely on a lot of the, hey, I'm just going to run this one command and I'm going to click this in the portal. We can make it more repeatable and more scalable, and that's going to give you so much more relief and flexibility and be able to scale and have consistency in your applications. Once you've learned and built these modules, once you've started to piece together IoT Hub and DPS as part of your applications, you can use that as the basis for so many, future projects. So thank you for the time today, and I hope this was beneficial to everyone.